Hello and welcome to What is Data Science by LMI. This introductory video is meant to give you an understanding of foundational data science concepts. We will cover what data science is, what it isn't, why it's useful, and the types of problems it helps solve. Advanced topics like the data science project lifecycle, data needs for data science, and machine learning will be covered in future modules. The most common description of data science is that it's an interdisciplinary field that applies techniques of statistics, programming, or coding, and subject matter expertise to extract knowledge and apply that knowledge within a particular domain. This knowledge, or these insights, are often future looking and have more scientific rigor, thus producing more actionable results, than just applying one of those techniques on its own. It is important to note that data science utilizes interdisciplinary approaches cohesively. Doing any of these disciplines in a vacuum and not in cohesion is not data science. A singular focus on statistics is often the responsibility of applied statisticians. Programming typically belongs to developers, and subject matter expertise can belong to business analysts. In addition to these, data engineers are usually responsible for standing up of infrastructure, like exposing data and creating pipelines, as opposed to data scientists. Now that we've defined what data science is, let's talk about why it's used and when it is useful. Typically, organizations turn to data science as a solution when they want to understand an event better or make better data-driven decisions about how their organization should function. For a business or government agency, the decisions using these insights often have impacts that save time, save money, increase readiness, or make more money. Data is the core of data science. It's in the name. So achieving success in applying data science to solve real-world problems is highly dependent on the accessibility, quality, and relevance of the data used. Data science can be applied to various kinds of problems and use cases, including descriptive, diagnostic, predictive, and prescriptive analytics. Descriptive analysis describes a scenario where you already have data, but want to understand more about what is currently going on. This analysis is about communicating trends and identifying behaviors. For example, an HR department might be interested in knowing how many people are attriting, and specifically, how many people in a certain department are attriting, and where is it happening the most. Analysis of this data describes the current state. Now that descriptive analysis has let you understand what is happening, you may want to understand why it is happening. Diagnostic analyses allow for a deeper understanding of phenomena and trends within data. What is causing a rise in attrition might be a question you're pursuing. This analysis still looks towards the past, much like descriptive analysis, but provides a more robust understanding of the situation. Given a thorough understanding of the current state, it is reasonable to wonder how changes may influence a future state. In contrast to the descriptive and diagnostic analyses, predictive analysis is forward-looking, and often what data science work is centralized around. It would answer new types of questions, like how much attrition do we expect? Or how much attrition do we expect given the expected compensation changes? Lastly, prescriptive analytics takes this one step further. Given that you're able to adequately model the future state as a result of input changes, you may want to know what you should do given a state of inputs. For example, given that there is a surge of demand for financial analysis talent, what action should I take to combat attrition? In summary, data science is an interdisciplinary field that applies techniques of statistics, programming, and subject matter expertise to different types of analysis that often build on each other: descriptive, diagnostic, predictive, and prescriptive.